Hi everyone, and welcome to this video. So in this video we are looking at how to solve quadratic equations using the completing the square method. As you might be aware, there's so many methods that somebody can use to solve a given quadratic equation. Maybe before we proceed, just allow me to do a quick recap of some of the terms that we are using. We know that, for example, that a quadratic equation is an equation which has this format. So the highest power of a quadratic equation is 2. Now when you're asked to complete the square of a given quadratic equation, what that means is that you have to leave it in a form ax plus p squared plus q. This is what is known as the completed square form. When it is in this form, it means that you have completed the square. Alright, having given that background, we can proceed. So let's look at question number A. X squared minus 6x minus 11 is equal to 0. How do we solve this equation using the completing the square method? Now, allow me to mention also that there are many approaches that you can take in completing the square, but in this particular video I'm going to use my favorite method, which you will see in just a minute. Okay, so the first thing that we do is we write down the equation that you have been given, and then you look at the coefficient of the first term, the one which has got power 2. So what you do with that coefficient is that you pull it out. Okay, you pull it out. In this case the coefficient is 1, so let's pull it out. But remember, when you pull it out, it's going to affect the other terms as well. Okay, so what is going to remain here is x squared minus, here we're going to remain with 6x, here we're going to remain with minus 11. Is equal to 0. So the next thing we do is of course these have not changed because we're dealing with 1 as a coefficient. However, you will see, for example, in question B, when we tackle question B, you will see that when we pull out the 5, the coefficient there is going to affect the other terms as well. So let's proceed. So the next thing that you look at is you look at the middle term, and then you look at its coefficient. So once you have that coefficient, it's negative 6, you multiply it by half. So when you multiply it by half, here you're going to have negative 6 over 2, which is equal to negative 3. So what do you do with this negative 3? You need to square it, add it to the equation, and then subtract it from the equation. This is what is known as a special zero, because there's basically the net effect of what you're doing is 0. You're adding a certain number to an equation and at the same time taking it out. So the net effect is 0. However, the importance of this special zero is that it's going to help us factorize, as you will see in the next steps. It's going to help us factorize the equation. So let's proceed. We have 1 outside there, then we'll maintain this term, x squared minus 6x, we'll also maintain it. Then we'll add the value, we'll add -3 and then square it. -3, square it, and then at the same time let's subtract it. -3 squared, and then there's we'll bring down that -11 there. Next step, you're going to see now that the value of the special zero is that it's going to help us factorize these 3 terms. So if you were to factorize this is what you would get. X, we'll pick it the way it is there, -3, then square it, and then we'll remain with minus, this is going to be 9 minus 11. Of course here it's is equal to 0, even here it's equal to 0. So 1 x minus 3 squared minus 20 is equal to 0. So at this stage we can now bring back the one which is the coefficient of the x squared, or the first term which we had pulled out. But of course, as I mentioned earlier, this is not going to have any effect because it's a 1. So the terms will pretty much remain the same. So we have x squared minus x minus 3 squared minus 20 is equal to 0. Let's rub this side so that we can have some space. Okay, so the next thing we're going to do now is we're going to say x minus 3 squared will be equal to 20. So the 20 goes to the other side of the equal sign. What do we do next? Let's introduce square roots, because the idea is we are trying to solve the equation, and as such we need to remain with x. We need to find the value of x. That's the ultimate goal. So when we introduce the square root sign on one side, we have to introduce it on the other side as well. So what this means is that this power is going to cancel with that, and we remain with x minus 3 is equal to plus or minus the square root of 20. We are making progress. So the only thing remaining now is we can send the 3 on the other side of the equation so that we can remain with x here. X will therefore be equal to 3. When it crosses the equal sign, it will become a positive, plus or minus the square root of 20. This means that, of course, we can simplify this one a little bit further. Plus or minus, we know that 20 can also be written as 5 by 4. 3 plus or minus the root of 5 multiplied by the root of 4. This is equal to 3 plus or minus. The root of 4 is 2, of course, so we have 2 root 5. So this implies that x is equal to 3 plus 2 root 5, or x is equal to 3 minus 2 root 5. So these are our solutions. Okay, let's go to the next question, which is part B. I'm going to rub this so that we can have some space. So we have been given 5x plus 4x minus 2 is equal to 0. So we're going to use the same method where we will pull out the coefficient of the first term. Okay, so when we pull out 5 from 5x squared, we're going to have 5. We're going to remain with x squared there. Then here we're going to have 4 over 5, sorry, x. Over 5 x minus, here we'll have 2 over 5. This is equal to 0. The next thing is we identify the coefficient of the middle term, and then we multiply it by half. So 4 over 5 multiplied by 1 over 2 will give us 4 over 10, which is the same as what? 2 over 5. So this we need to square it, add it to the equation, then subtract it from the equation. So we'll have 5 x squared, we'll bring that one down. Then this one again, we just bring it down the way it is. And then we add 2 over 5, we square it, subtract it. 2 over 5, we square it, and then we bring down that one, 2 over 5. So we have 3 terms here which we can easily factorize by just picking the x there, and then we pick what is inside the brackets there. It's 2 over 5, then put the square root, or square it rather. So we have factorized that part. Next thing, we just deal with these remaining constants. So we're going to say minus, when we square this one, we're going to have 4 over 25 minus 2 over 5. Is equal to 0. Next, we're going to say x plus, of course it's in brackets, plus 2 over 5, square it. We need to evaluate that. Common denominator is 25. 25 into 25, it's 1. 1 times negative 4 is negative 4. We need to be very careful with the signs there, because we can easily get it wrong. And then 5 into 25 it's 5. 5 times negative 2, it's negative 10. So this means that we have negative 14 over 25. So negative 14 over 25 is equal to 0. Let's rub this part so that we can have some space. So the next thing we're going to do now is we need to bring back the 5 that we had put out. So when we bring it back, it's going to look like this: 5x plus 2 over 5 squared minus the 5 is going to cancel out with that, and you remain with the 5 there. So we have minus 14 over 5 is equal to 0. Next we can say 5x plus 2 over 5 squared is equal to 14 over 5. This number we take this number and send it on the other side of the equation of the equation, and then it's going to be positive when it crosses the equal sign. So next, let's deal with this. We multiply by the reciprocal, meaning we multiply both sides by 1 over 5, multiply both sides by 1 over 5. The idea is we want to get rid of that, so that that and that goes, and here we'll remain with x plus 2 over 5 squared is equal to 14 over 25. Again, we want to get rid of the square there. What do? We introduce the square root sign on both sides of the equation, so that this square and that root sign cancels, and you remain with x plus 2 over 5 is equal to plus or minus the square root of 14 over 25, which is equal to the square root of 14 over 5, plus or minus, of course. So we're going to say x plus 2 over 5 is equal to plus or minus the root of 14 over 5. We can now our interest is to remain with x, so we can send this number on the other side of the equation, so that we can remain with x is equal to minus 2 over 5 plus or minus the root of 14 over 5. This means therefore that x, I'm running out of space here. Okay, can I do this? So x is equal to minus 2 plus the root of 14 over 5, or x is equal to minus 2 minus root 14 over 5. So these are the two answers, or two values of x. So yeah, thanks for watching, and see you in the next video.